Algebra 2, Lesson 77, Advanced Radical Equations. So we've already done radical equations like this here, where we'd see a square root equals a number. We'd have to square both sides, solve for, and once we square both sides, the radical goes away. Then we can solve for the number. Now, when they talk about advanced radical equations, what they mean is this. We now have a cubed root, multiple unknowns, and then it's set equal to 0 or a whole number. So, let's go to our example. There it is. Okay, so this is our equation. We have the cubed root of x cubed plus 6x squared minus 4 minus x minus 2 outside the radical. Our first step is going to be to move anything that's not a radical to the other side of the equation. So that means this x and this 2. So we'll go ahead and add those. Those cancel, and then our new equation becomes this. We have the cubed root x cubed plus 6x squared minus 4 equals x plus 2. From here, we can get rid of this cubed root if we cube both sides. So I'm going to take this, put it to the third power, this to the third power. The left side is very simple, so that's just going to remove the radicals. So let's get started on the right side. So when we have x plus 2 cubed, what we actually get is x plus 2 times x plus 2 times x plus 2. So we're going to have to FOIL. Let's see here. This is going to give me x squared. This will give me plus 4. This is going to be 2x, and that's going to be 2x. So I'm going to have plus 4x in the middle, and then I still have to multiply all of this by x plus 2. So we'll multiply one more time. Here, x squared times x gives me x cubed. X squared times 2x gives me plus 2x squared. 4x times x gives me 4x squared. 4x times 2 gives me plus 8x. Then 4 times x gives me plus 4x. And then 4 times 2 gives me plus 8. Oops, off the paper. All right. Then we're going to add like terms. X cubed stays the same. 2x squared and 4x squared combined to become 6x squared. 8x and 4x combined to become 12x, and then 8 stays the same. Now on the left side, remember we said that this cubing would remove the radical. So we have x cubed plus 6x squared minus 4 on the left side. From here, I'm just going to move all my x's to one side and all my whole numbers to the other. So I'll subtract x cubed, subtract 6x squared, subtract 12x, minus x cubed minus 6x squared, minus 12x. And then I'm going to move the 4 to the other side by adding 4 to each side. So we see this cancels, we're left with, oh, these cancel. So on the left side, we're left with negative 12x. On the right, this cancels, this cancels, this cancels. 8 and 4 is 12. Now the last step, all we have to do is divide by the coefficient of negative 12. That cancels, so then I get x is equal to negative 1. And that's my answer. So nothing new. This is all stuff we've done before. It's just a few extra. It's just all being added together, and it can be a lot of work, but it's not that difficult. You just got to make sure you keep track of adding like terms and you multiply and move around the equation correctly. Now the next example we have here is multiple radicals. What we mean by multiple radicals is we have a polynomial radical and a single term radical all in the same equation. Now the way we're going to deal with this is we're going to attack the most complex radical first, or the polynomial radical. So we're going to isolate that or get it all by itself, and then eliminate that radical, and then move through the equation to get rid of the second radical after we've eliminated the first one. So what that looks like is this. Let me make our equation magically appear. Ta-da. Okay, so this is our equation. And like I said, we're going to start by attacking the most complex radical, that being the polynomial. So we're going to move everything except that radical, including the small one. Whoops, that should be a minus, to the other side. So then we get square root of k minus 5 is equal to square root of k minus 1. And then we're going to go ahead and square both sides of our equation. The left side, again, is pretty simple. We're just going to get k minus 5, eliminating the radical. The right side, we have to FOIL. So, we'll go ahead and write this again, and then start multiplying. Square root of k times square root of k is just going to give me k. Negative 1 times negative 1 gives me positive 1. And then negative 1 times root k gives me negative 1 root k. And k times negative 1 gives me negative 1 root k. I add these two like terms to get negative 2 root k. So, this is really sloppy. Let's rewrite this. So I'm going to get k minus 2 root k plus 1 on this side. Now what I see is I'm down to one radical. So I'm going to go ahead and solve the way I normally would if there's only one radical in my equation. I will move everything that is not the radical over to the other side. So I'll subtract k, subtract 1. This side cancels, and I'm left with negative 2 times the square root of k on the right, and then on the left the k's cancel, and I have negative 6 on the left. From here I'll divide by the coefficient of negative 2. The negatives cancel, and over here I'm left with 3, and here I just have square root of k. So if 3 is equal to the square root of k, if I square both sides, I get k equals 9. And that's it for these radical equations. If you have any questions, let me know on Moodle, and I will see you in class.